Well, okay. I think that we have already 4 minutes after 2 o'clock, so it's time to start our seminar. And today, as a speaker, we have Marek Kasztelnik. Marek is a staff member of the Laboratory for Informatics Methods in Medicine, which is official name. And he is a very experienced developer of systems supporting scientists in computing, efficient usage of high-performance computing system. And recently, Marek is leading two projects at CypherNet, which are somehow in the core of artificial intelligence. And so the topic of today's talk will be related with this artificial intelligence. Well, the title is, to some extent, I think, for people in Sano may be misleading in the sense that this organizing of conferences may also be applied, I can imagine, for example, for conferences of medical doctors and for communications with medical doctors. So that's all for introduction. Marku, screen is yours.
Thank you, Maria, for the introduction. Hello, everyone. I'm Marek Kasztelnik. I work in CypherNet, which is the HPC center, but we don't only have very huge clusters, but we have teams with huge experience in different fields. So as you probably know, the CypherNet team is the original creators of the Sano. So we are very proud that we were able to fund this huge organization like Sano. And during this talk, I will be talking about one of the research projects we have in CypherNet, and I have a pleasure to lead this project from the CypherNet point of view. The project is called the Meetween, which is a purely AI-focused project. So in the scope of this project, we'll be trying to improve the way how the Europe can communicate between each other. So during this presentation, I'll be showing you the goal and the vision of the Meetween project. Next, I will show you some building blocks for the project and how this kind of building blocks can compose together to create the whole project and the whole vision we have in Meetween. Next, I will show you some elements connected with CypherNet. I will show you how we are making the project like Meetween possible. This is quite important because right now, if you want to create something AI related, you require a lot of GPUs, a lot of experience how to distribute the load on the HPC clusters, and all this experience is inside the CypherNet. But the CypherNet is a national organization, and sometimes the project requires something more. So also we'll show you possibilities to get more GPUs, more resources, more clusters for your project in order to run bigger, more advanced trainings for AI. And at the end, we'll have some summary, and if you have some question, I'll be happy to answer them. So the Meetween project is a European-funded project, started 1 year ago. And our goal is to create large AI models, to enable the next generation European video conference solution. By that, we think about breaking the barriers between the languages. Seamlessly translate the speech, text, do some summarization, and introduce some nice features I will be showing you next. And in the scope of this project, we as a CypherNet are delivering some solutions connected with HPC. So we are delivering the CPUs and GPUs, as well as solutions to run huge trainings on a distributed data. So how to distribute the data, how to configure the whole environment, how to make it sustainable. And as you can see at the bottom of the slide, this project has very strong consortium. So we have the Translated, which is leading this consortium. This is one of the biggest translation company in Europe. And also we have some research institutes like FBK or Karlsruhe. And also we have a strong business inside. So we have the Zoom, which is leading the task connected with applying the models we created in the scope of the project to open source communication solutions. So the vision of the project is to deliver a multimodal model which allow to break the barriers between the languages. So for example, if we have a teleconference and we have participants from Poland and from Spain, I can speak in Polish and my colleague in Spain will hear the Spanish version of my talk and vice versa. So this is the first goal we have in the scope of the project. The second one is to deliver two bots. The first one is a butler. This is something you already can find in commercial solutions. So like summarization, checking if there are some tasks for me in the scope of this meeting, or please sum up the most important things. So just like solutions for the Meetween for the teleconference. And last but not least, I think the most challenging and the most controversial one is a bot which can replace you in the scope of the meeting. So the goal is to have your avatar, which you can train before the meeting. So you can give him some key points which should be presented during the meeting. And if you are not able to participate in the meeting, you can send the avatar there, and the avatar will do whatever you want. So can show some key points, can answer some questions according to the guidance you gave between the meeting. Also, in the scope of this project, we are putting very strong emphasis on responsibility. So all the training data should have some protection against harms, against the discomfort and biases. So this is also an important goal for a project. We are also providing all these elements as an open source solution, where you can host everything we develop in the scope of the project in the closed environment, and you will have 100%. You will be 100% sure that no data leaks to some China company or to the US company. Everything will be installed on your servers. So our ambition is to, at the end of the project, to release 4 artifacts. The first one is a Manospring, which is a multimodal and multi-languages dataset for training speech LLM. The second artifact is LLM itself. We are planning to release a free version of the speech LLM in the scope of the project. The third artifact is a task-specific models. So we will be training the downstream task based on the foundation speech LLM model. And last but not least is the Speech M, which is a speech performance evaluation criteria and holistic metric solution. So this will be a service which allow you to benchmark your AI model and produce a ranking list. So our plan is to use the pre-trained base model. Then we already done it. We defined the downstream task, And by using the pre-trained model, we are training it once again for concrete solutions. So, for example, for summarization, then we, in the scope of the project, will collect a large amount of data. And of course, we'll use a huge amount of GPU for training and for validation of the model. And at the end, we are planning to apply our results to open source video conference platform and make it available to everyone from Europe. So Cyfronet is mostly visible in two elements here, in creating the benchmarking solution, as well as providing the HPC resources, as well as experience we have connected with training large foundation models. So first question which can arise is why choosing the foundation model, why not start from the scratch and do something from the ground? So the answer is very simple, because the training of the base model is extremely costly. So for example, here you can see the training cost for Llama 3.1 model, and you can see the huge number of GPUs used to train this model, as well as a huge number of CO2 emitted to the atmosphere. So the next element is choosing the right foundation model. So this was done at the beginning of the project. We define what kind of foundation model we can use to retrain it later on. So we collected a huge list of existing models and check the conditions for the model, and do some benchmarking connected with the goals we want to achieve in the scope of the project. So if you are interested, all the tests we made on those models can be found in the public deliverable we have done in the scope of the project. And the result is that for the speech LLM, we choose the Llama model, and we are retraining it by basing on the additional data we are collecting in the scope of the project. So now I will go briefly through all this artifact we want to release and show some details connected with it. So the first thing which needs to be done in order to train the model, you need to have the data which allow you to train the model. So here we can see that the lag and the very big difference between the public companies like Facebook or Google. They have a huge amount of data which can be used to train the model, and this is not the case for the project like Meetween. So at the beginning, we started to collecting publicly available data from different sources, and we also make it publicly available. So we prepared the first version of the ManuSpring, which is a set of downloading scripts which can you use to download all the training data we use to train the first version of the speech LLM. It contains over 561,000 hours of speech data, and we are covering 24 languages, European languages, and 4 additional non-European languages. We have prepared the download scripts for different open source data sets. So everything is composed in one place, and you can use it to download the data. The first release of the ManuSpring is on a Hugging phase. So you can use it and download all the elements we use for the training. So let's take a look into the challenges connected with collecting the training data. So the most important thing and the most challenging one are licenses. So the project is 1 year old, and during this small period of time, we had very big changes in licenses. So for example, NTDEX and MASC are very high quality data sets connected with the TEDx talks with translations for many languages. And more than 1 year ago, it was possible to use all these data sets for training. Right now, the license changed, and for example, we was forced to remove this training sets from our manuscript. So the licenses, which are changing rapidly right now, are the most important challenge we had while collecting the data. The second challenge was connected with fetching problems. So, for example, we started to download the CC licenses movies from the streaming platform, and there are some throttling issues. So we was forced to implement some solution connected with the proxies to avoid the banning of concrete IPs. So this is another challenge. The third challenge is connected with storing the data. You can of course store your data on your laptop, but then is a problem with transferring the data between the HPC center where you are performing the training and your laptop, and vice versa. So to solve this issue in Cyfronet, we have two possible solutions. The first one is S3 compatible storage, when you can store all the data. The second one is a shared group directory on HPC clusters we have in Cyfronet, and both of these resources are used in the project to store the training data, as well as checkpointing for the models and the results. So here you can see the list of the training data we used to for the first version of the speech LLM, and as you can see, currently we have 20 terabytes of data used to train the model. And the good news is that the manuscript is continuously growing. We are adding additional data source for the data. So at the end of this project, this repository will be at the worst case scenario tripled, but I believe that we'll do much more. I believe that at the end we'll have more or less 100 terabytes of the training data for multi-languages models as we have in Meetween. So the second artifact is a speech LLM. So this is the large language model compatible with 24 languages with many options to consume the data and produce. So for example, you can put a video or text as an input and produce also a text or video at the end. So all the training procedure, all the source code for the training of the model is also publicly available. You can see the first release of the speech LLM in GitHub in our Meetween organization. And in the scope of 4 years project, we are planning to release 3 different generations with 4 different sizes, S, M, L, and XL. So here you can see the architecture of the first generation of speech LLM, and as you can see, this is a multi-modality model. When we have many encoders translating everything into the text representation, and then it goes to the LLM we have. At the end, you have the text. In the next generation of the model, we are also planning to add decoders at the end to produce not only text but also audio or video. We are building the speech LLM on existing foundation models. So as you can see, we are using different versions of the Llama depending on the size of the parameters. And the first version of the speech LLM is also released. You can see it on Hugging Face in our Meetween organization. So the first version was released 11 days ago. The second one will be done in the second year of the project, and the third in the third year of the project. So to train the speech LLM, even in this first version, we already use a huge amount of GPUs. So here you can see the GPU consumption on 2 clusters we are using for the training. We are using Athena and Helios, and as you can see, we already consume for the first version of the LLM 310,000 GPU hours basing on the A100 GPU card. So this is not the biggest one, but it's a huge amount of hours, and if you are converted into the real money, you can see how costly it is. And the question is, what is generating the cost? It's not only the training itself, but first element which is consuming the resources is collecting data. So cleaning, pre-processing, segmentation, all these elements required some CPUs or GPUs. And in the previous slide with these graphs, I didn't show the CPU usage. It was only a GPU, so additional resources also was used to download the data and pre-process the data. The second element connected with consuming the GPUs and CPUs are connected with experimenting. So in the scope of the first year of the project, we perform a lot of experimentings with different architectures, with different settings. We perform a lot of Jello runs, and they consume a lot of resources. Next, we done the training. This is the most important factor and consume a lot of GPUs. And right now we are doing the same. So we are taking the foundation model and producing the downstream tasks and training the downstream tasks. This is also something which is consuming a lot of GPUs and CPUs. And at the end, we are also validating the models. This is also something which consumes a lot of resources. So the downstream tasks, I will not say much about it. I can also show you the list. This is something we want to train our foundation model and do many models connected for concrete downstream task. But this activity started a week ago, so we don't have any results yet. But very similar to the speech LLM, all the downstream tasks will be released as an open source, and you can download the checkpoints on the Hugging Face. The last artifact I was mentioning is a speech M, which is extendable AI model benchmarking service. So we got the first prototype of this service. On the left side, you can see the first version, which is publicly available. And on the right side, you can see the architecture of this solution. The interesting part is connected with the connection with the HPC itself. So we have a web-based application where a user can upload the hypothesis, and next, all the hypotheses with the ground truths are transferred into the HPC solution, to the HPC cluster when we are evaluating the results. And this is done in an automatic way, and thanks to the HPC architecture, we can do it in parallel. So in the speech M, we have some nice solution connected with delegating the user rights to the infrastructure. So it looks as follows. When the user enters the web page, he can click the login button. Then we are redirecting the user into the PL grid as a single sign-on solution, which is based on Keycloak. And at the result, the user details a token are returned to the web application. Then we can connect another service, which is called the CCM. This is a Siphon Certificate Manager, when we can authenticate ourselves by using this token we get from the SSO. And at the result, we are receiving the short-lived token, short-lived SSH certificate, which is valid starting from 1 hour to 24 hours, and we can use it to delegate user rights to the infrastructure. So then we can establish the SSH or SFTP connection, transfer the data to the HPC, and run the jobs itself. We're using the Slurm RSD for this. This is the REST API for managing the jobs on the HPC. So now I can show you briefly how the SpeechM looks like in action. Can you see different tab from my browser?
Yes.
Okay. So this is the live version of the SpeechM. So as you can see, we already registered some tasks. So for example, machine translation or speech translation, speech summarization. Some of them are already configured with the test sets. So as you can see, we have plenty of test sets already installed. We have DeepCo, ACL 6060, and others. And also we have some tests for some testing models which are already evaluated. So for example, you can see, let me select the speech translation, or not this one. Let's try to maybe use this one. And as you can see, we are producing some leaderboards which can be sorted according to concrete metrics. And once login, I will use my PL Grid account. I can submit my models. So for example, I have one of my models. I can select which tasks are compatible with my model. So I can say that my model is doing the machine translation, and then I can evaluate my model. So for example, here I can upload the hypothesis. Let me find it. Yeah. So once the hypothesis is uploaded, I can evaluate my scores according to concrete metrics. So for example, let's run the VER metrics. Here everything is done in automatic when the data are transferred to the HPC. The job is started, the evaluation is triggers, and basing on the type of the evaluation, it's started on the CPU or on the GPU. So for example, the Blue Earth requires the GPU, so the job is started on Athena, and the VER also is only using the CPU, so it's triggered to Ares. So once the evaluation is done, everything is uploaded back to the application, and you can see the result. For example, here we can see that I get 0.0, which in the case of VER metric is very good. So everything is in perfect match. And this application is a first prototype, but we are planning to release the first official version at the end of this year. Let me come back to the presentation. So the important thing connected with SpeechM is its extendability. So you can define as much task as you want. You can upload as many test sets as you want. Also, you can define different evaluators connected with metrics. And this can be done by simply uploading a template for running a job on the HPC infrastructure. Everything else is done in automatic way. You can also configure here if the CPU is needed or the GPU is needed. Everything is in place. So by using this simple web user interface, you can configure all the elements connected with evaluating a script. And what is nice is that we are using this solution for the EWSLT 2025 challenge, which will start at the beginning of April. So if you have LLM you want to test, I can encourage you to participate in this challenge. So this was the overview of the Meetween project, and now let's take a look into next slides when I will try to show you how the CipherNet makes this kind of project possible. So as you can see from the slide, the simple answer is PL grid. But why? It's because we need 5 elements for this kind of project. So first element is data management. The second is computational management and access to computational resources. The first element is scientific team management, then training and troubleshooting. So all these elements are built into the PL grid itself, where you can apply for resources, you can manage a team, you can ask for training and ask for help from the expert we have in CipherNet, but not only in CipherNet, but also from the organization which are participating in the PL grid. So for example, you can have some resources in Warsaw or Poznań, but saying the truth, the CipherNet right now is the biggest one in PL grid infrastructure. So to get a resource, we get a dedicated portal, which is called the PL grid portal PL grid PL. And once you register to this portal, you can request computational resources which are given for free for Polish researchers. As far as I know, many Sano members already have accounts in PL grid and are applying for resources. But I'll briefly show you how this procedure looks like. So you can request for the grant. Then you need to provide some basic information about your grant, assigned a research team to this grant. Then you are estimating how many CPUs, GPUs, or memory you need to perform your research. So for example, here I requested 100,000 GPU hours on Athena and 100,000 gigabytes in Athena and Ares storage. Next, I need to provide some more detailed information about my grant, which is needed for our expert in order to validate if the grant is correct and the requested amount of resources are too big or too small for this kind of activity. During the process of submitting and managing the grant, you have the clear information on which state your grant is. And once it is active, like for example, for the Meetween, everything is populated to the infrastructure. So after 1 hour of accepting the grant in the portal by our administrators and the operators, everything is populated to the infrastructure. So you can log into the infrastructure, check if the grant is already configuring the Slurm queuing system. Also, the group storage is configured for you. And if you are requesting access to the S3 storage, then also it's automatically configured. You can use it just like this. Next, you need to manage your who can access your grant, who can upload the data and run the computation. So for this, also in the PL grid portal, there is a dedicated views for managing the teams. So you can create your teams and easily add new members. Also, you can generate a link and send to someone in order to join your team, or you can send the invitation through the mail. Everything is done in an automatic way. Of course, in some cases, you need to approve the user who wants to join your team, but it's very convenient and just 2 or 3 clicks on the user interface, and everything once again is populated to the infrastructure. The last thing is connected with training and troubleshooting. So in the scope of PL grid, we have a dedicated team for this. So if you are establishing a new team, like we done in the scope of Meetween, we prepared a dedicated trainings for the project. And if there are some troubleshooting, we have a help desk where you can create the ticket. We have very strong and short SLAs connected with the tickets. So someone needs to respond to you. So it's not the case that you will be waiting for 2 months in order for admin to reply to your issue. Usually it's done in the scope of hours, or when the problem is quite complicated, days. So the PL grid infrastructure itself can give you everything connected with access to computer power, to the storage. And this is something we are using in the scope of Meetween, and it works perfectly for us. But sometimes PL grid is not enough. And as you can see from the graph I showed you, we already use 310,000 GPU hours, and we are planning to use much more. And this is not the amount we can get from the PL grid. So we are looking for some additional sources where we can get access to the GPUs. And where to look it? Also, the short answer is the Euro HPC Joint Undertaken, which is an initiative of the European Union when they connect the biggest HPC institute in Europe. And they have a clear path how to apply for the resources. What is unique in this initiative? It's that not only the researchers can apply for the resources, also the companies can apply for the resources, and there are some dedicated calls for this kind of activities. So the key objective of the Euro HPC is to build a unified solution for the accessing the supercomputing in European, and produce one of the biggest HPC technologies in the world, but only dedicated for the European Union. So in the scope of Euro HPC Joint Undertaken, there are right now 3 powerful HPC installation you can use and apply for the resources. So it's Mare Nostrum, Leonardo, and Lumi. For the Mare Nostrum and Leonardo, they are based on NVIDIA solutions. Lumi is very special because they are based on AMD solution, but according to our benchmarking I'll be showing next, it's also a good solution. I know that the AMD can be scarce for AI solutions, but it's not that bad. And right now the technology change in the way that the AI training can be done quite easily also on the AMD installation. So in the scope of Euro HPC, there are different calls. The biggest one is a extreme scale access mode. In the scope of this call, there is a quite difficult and time-consuming procedure of applying for the grant. So you need to provide a proposal, then it needs to be validated by the members of the Euro HPC, by the external user experts. So this call is quite difficult and time-consuming, but there are a little bit smaller one, which are much faster if you are comparing from the submitting a grant to accessing the data. And those grant is dedicated for the AI. So as you can see, the procedure of getting access to the HPC resources, it's much simpler. So you need to submit a proposal, then there's a peer review, and there is a decision. And at the end, HPC Center will contact you and give you access to the clusters. And also there are 2 other very small calls, which is called the benchmarking access and development access. And this is something you can use and should be using in order to test if these HPC clusters are for you. Right now, in the scope of the Meetween project, we applied for the Morena-Strum resources. Also, we started to perform some performance testing on the Lumi supercomputers. This is something I'll be showing you next. Because if you, for example, are using the PL grid infrastructure and the Helios we have in Cyfronet, then there is a question, where should I move my calculation in order to get more GPUs? While choosing the best cluster for migrating the model training, or choosing the HPC cluster where the AI should be trained, we need to answer potentially 3 questions. The first one is connected with the architecture of the solution. So you need to take a look not only at the level of GPUs or CPUs which are used in the infrastructure, but also on the fabric. So how the GPUs are connected together, how the nodes are connected together, how to send the information from one GPU to another GPU. And this can be a huge factor connected with the performance, how the model can be trained. If you are looking into product white papers, they are quite accurate. So if you are looking at the single GPU, you can take the performance evaluation directly from the white papers, but it's not the case for the multi-node, multi-GPU trainings, where the factor is fabrics are making a huge difference. We are right now doing some benchmarking connected with different infrastructures, and we started with Helios. And we also performed the same benchmarking on Lumi supercomputer, and we use the IPM solution, which is based on PyTorch, and it tests the collective primitives. But before I show you the result, I would like to show you the architecture of the Helios node and the Lumi node. So for example, for the Helios node, as you can see, we have this Grace Hopper solution where each GPU is connected with all others. So there is a direct link between the GPUs. This is not the case on the Lumi supercomputer. So for example, if I want to communicate between GPU 5 and GPU 0, I need to go through GPU 1. This is the shortest path. So there are some costs connected with communicating between the GPUs. The same case is for communicating between the nodes. And we perform two primitive benchmarking. The first one was connected with MapReduce. The second one was connected with sending the part of the huge matrix to all GPUs. And as you can see, Helios is a little bit better than the Lumi, but they are very comparable. So if your training is not huge like ChatGPT, then there is a difference between starting from several hours to several days of training, but it's not the breaking barrier that you cannot afford. And the good thing about the Lumi is that they has a lot of GPUs. It's not like in Helios where we have more than 100, they have more than 1,000. So the amount of the resources you can get quite fast is much bigger. And this second test we perform is connected with bandwidth connected with sending different size of the messages between the GPUs. As you can see, also the Lumi is a little bit worse than the Helios, but it's not bad. So according to the result we got, we are sure that we are able to quite easily move our training into the bigger scale, also on Lumi. And another thing connected with the Euro HPC, which is very nice, is the Epicure project. So if you have a grant on the Euro HPC, you can apply for assistance in the scope of the Epicure project. There is a dedicated teams across the Europe which can help develop your solution on the HPC clusters connected with the Euro HPC. Cyfronet is a member of this project, so we have also in Cyfronet a dedicated team who is helping the project to, for example, run the big trainings on the Lumi cluster. As far as I know, right now we are supporting the AI training on Lumi, where they are using more than 100 nodes to train the model. So to sum up the Meetween project and also the situation in the HPC clusters, we came from way and long way from manually configure everything to some automatic solutions. So the solution like PL Grid or Euro HPC can boost up the project like Meetween. The configuration of the resources, access to the resources is quite easy right now. Applying for new resources is quite easy right now in Europe, and the boom for the AI is huge, and the European Union can see the importance of these activities and try to simplify. They are trying to simplify everything for the researchers. So it's very good time for all the project to apply for this kind of resources. I would like to also once again said that all the elements we'll be doing the scope of the Meetween project will be released as the open source. So I invite you to take a look into the repositories we are providing on the Hugging Face, also on the GitHub. And also from my point of view, from the Cyfronet point of view, we are here to help. So if you have some ambitious scientific or commercial project, we can help. So that was my last slide. Thank you very much. I'll be happy to answer all the questions. Yes,
Thank you very
Jacek?
much. Yes, and it's time for
Yes, hello, can you
question.
hear me?
I think that we have Janek Meisner willing to ask or add something.
Yes, can you hear me?
Yeah, of course.
Yes.
Okay, so just a quick question. I clearly show that, well, very well presented aspect of, well, resource usage. So that's certainly it's an AI, so it uses lots of GPU resources and probably CPU. But I also saw some really big files for training, like 20 terabytes, if I am correct. So how would you summarize what kind of resources are, well, in most demand for this application? Is it more
Of course,
like,
GPU.
I don't know, memory? Of course, GPU, but
of course, GPU.
yes, or network, yeah. So the
this
GPU
is
the most.
Short answer.
Okay,
Short answer,
so
GPU.
GPU. Yeah, thank you.
You know, the storage is quite cheap, right? So there is no problem of getting access to 100 terabyte of the storage.
Okay, and
this is something which is really, really cheap. Access to the GPU is quite expensive.
Okay, and
if you are talking about the research project, we are trying to do it for free for Polish researchers. But right now, the Cyfronet also has some proposition for external users connected with the research and also from the enterprise. And if you want to know some details, you can find more information on our webpage.
Okay, thank you. And I think that for memory, it also fits into typical nodes as you are doing training on
But from the
nodes, yes.
memory, you are referring to the memory, to the RAM memory or
RAM
GPU
memory,
or...
yes, because you know, like we have some cases that have the problem with not AI cases that cannot fit into typical nodes, like they require about nearly 1 terabyte of RAM per node, which is too much, for example, for RS and I think, so yes. So
this is very interesting thing of how to split the data in order to fit to the architecture you have. So, for example, for the AI-related things, we had a lot of experiments when we divided the tensor, the big one, into the smaller part and distributed it among the GPUs. And before we performed the training, a lot of experiments connected with different architecture for the learning was performed.
Okay, so thank you very much, because this is really interesting also for other cases that we are working
on. Okay, many thanks. Marku, I have a question related somehow to what I started the seminar. Well, let's assume that we have a number of a situation which is in hospital where medical doctors and nurses are going around and let's say give some comments or some assessment of the status of health of a patient. And do you think that it could be the system you are working on in Meetween can be somehow helpful in the sense that it could recognize this natural language, make a kind of report?
I think that's the broad topic. If we are talking about collecting the data from different sources, not even from the Polish literature, but also from external languages, and trying to look for the cases which are similar to the case described in the hospital, for sure, yes, because then you can use the model we are using to translate everything into concrete version and then do, for example, the summarization. So the AI is a general purpose technology. So the solution we are providing can be applied also for medical cases.
And also for gathering this information and transforming them into something what could be somehow, let's say, in a standard form. Do you think that it will be possible to have this in form of tables?
We have this foundation. Yeah, so we have this foundation model which can translate between the languages and do some transformations, but then you can also train further the model and for concrete downstream tasks connected with, for example, gathering the data and transforming from the tables representation to the text representation. Of course, this is doable. It requires additional training sets, and it can be done by using the foundation model we are releasing the scope of the project.
Okay, so most probably it is something what can help in some way in gathering data from, let's say, medical doctors who have no time to put this information into using the keyboard. So it will be
Sure.
It could be something.
You can record it as an audio and transform it the text. Yes, our model is the solution for this.
Well, and what is the time scale of the project when, for example, such feature will be available?
So this is the 4-year project. We are after the first year of the project, so still we have three more years. So the most advanced speech LLM will be released after 2 years, and then we have the last year, which is needed for applying the solution we created into open source telecommunication platform.
Oh, well, Well, Maćku, please go on.
Okay. Thank you, Marek, for this overview of this project and nice presentation. So I have a kind of general question, because also you have a lot of experience, we know, about running scientific applications, simulations, simulation models on HPC, yeah? For example, the model execution environment. So can you somehow try to summarize what are the main differences between these typical modeling jobs and the way people are running them, like these campaigns, for example, to these AI jobs that you are managing now in this project, yeah? This kind of summary of differences.
Yeah. So for the solution, like running the campaign for a cohort of the patients, usually you are using the same model with different inputs, right? So the main goal here is to run them as much as possible in the shortest period of time. So you don't have the problems connected with optimizing the architecture connected with transferring the data between the GPUs, accessing the data, because you are running quite small according to comparing to AI training simulations on a smaller data, right? And for the AI, we are running the big training, which can take days and consuming hundreds of nodes. And you need to monitor the progress of the training. So if the training is going to the good direction. So there are different monitoring solutions which are used, different set of transferring the data. So for example, if you want to transfer 20 terabyte of data between the S3 and HPC, we need to spend a lot of time transferring the data. So it needs to be done in advance, need to be prepared in a correct way, where it's not the case for running the campaigns where the input data, for example, the imaging, which is quite small, for example, 1 gigabyte of image, you can transfer quite easily to the HPC and run in parallel.
Yeah. And thank you. And yeah, so there are also some similarities, yeah. And do you think
Yeah, of course.
some of these tools can be reused between these two, types of applications?
So in the scope of AI, we have two steps, right? So the first one is training, the second one is inference. Also, the second element is quite interesting. I was not mentioning this in my presentation, but it's something also we are developing in SciFrontend right now. So the inference is very similar to the simulation of running the cohort patients. So how to scale up in the dynamic way the number of nodes responsible for answering concrete user question. So you can take a look into a new addition to the portal we have right now in Pillar Grid portal. When you can apply it for tokens, you can use to inference the models we are hosting in SciFrontend. So this solution is very similar to the solution connected with running the cohorts. And you are right, there are some similarities. And of course, in the medical work, the AI-related things are coming even more important right now.
Yeah. I was actually going to ask about this inference, because this is, I think globally it's taking even more resources, than the training.
Yeah, depending on the scale, but yes.
Yeah, of course, depends whether you are a research center who is training the models or then providing it, to the users. But yes, SciFrontend is doing this second part as
So
well.
for example,
so
for PLIC, we are hosting the inference solution. Yeah.
Okay, thank you. Question from Wiesław.
My question is about feasibility. So the project I have been doing is about brain modeling at the nanoscale, meaning trying to model the synapses, because of course many things are going at this level. So far, we don't have this kind of data to map the whole brain at the level of synapses, but we hope that one day it will be feasible. So what I have been trying to do, I have estimated what sort of resources and storages are needed. And from this initial analysis, the requirements are that, let's say, if I'd like to have a morphology model on the best supercomputers, meaning Frontier, I can only partly accommodate, so meaning exaflop and 37 petabytes. So the question is, what resources we have in Poland or in general in Europe in comparison to the frontier? So meaning if one day I have this kind of data, can we still run this kind of model, or it will be not possible?
For sure not in the following year, but we are going into this direction, and the technology changed quite rapidly. So something what was not possible 3 years ago, now we can do it. So I believe that not right now, but in the near future, we will be able to store this amount of data and perform this scale of computation. So right now, the biggest initiative we have in Poland is in Europe is this LUMI initiative, and this is the place where you should be looking at the beginning. So I don't have access right now to the newest statistic of the LUMI supercomputer, but it can be quite easily findable on the web page, and this is the place I will be looking for the first solution to store this kind of data.
If you are saying in near future, you have in mind 1 year, 2 years, 3 years? No, it's hard to say.
It's hard to say. It's really hard to say.
Okay, good.
You know, it depends on so many factors. The technology part is one thing. The political thing is the second one. And if we can predict something from this first thing, we cannot predict the second one.
Okay. Yeah, the same is with data acquisition, because so far,
yeah,
you know, basically from Google there is only 1 cube millimeters at the level of nanoscale. But recently I saw data from China. They have a big chunk of maybe 10 cm cube. So probably within the next 3 years, they might be able to get data for the whole brain. And the question is where we find the resources to process it. Okay, good. Thank you.
Yeah, I can also add just one quick comment that what we can observe now is that there is a lot of investment also in Europe, in this HPC power for AI, so this AI factories and all these big initiatives, which means that a lot of resources that are being installed or will be installed are mainly GPUs. So if people are trying to use other types of computations, for example, simulations or some other data analysis, then it's good to think whether the solvers we are using or the algorithms can really use GPU, for that. And we have seen recently that, for example, ANSYS Fluent for the fluid dynamics simulation CFD solver supports the GPU, and it works very fast on that. So I think, this is a good opportunity to kind of reuse these AI resources for some other type of applications as well,
Yeah, precisely.
And we should, I mean, we should consider it when planning, yeah, some larger projects, including this brain data analysis. Yeah. Okay. Yeah, Marian asked me to lead the discussion because he had to move to some very important meetings. So, do we have some other questions from the audience? Okay, I don't see. Yeah, so let's thank Marek again for his presentation.
Thank you for having me.
Thank you, everybody. Yeah, for attending and discussing. And yeah, everybody is also invited to join the Euro HPC Summit that is starting this week in Krakow. I think you can still register, but only for the online participation. So there will be a lot of presentations about these very similar topics that Marek was showing us today.
And if you also want to talk about the Meetween project, there's a good opportunity because tomorrow I will be there, and also the Sebastian Partier, who is the coordinator of the project, will be participating in the Euro HPC Summit conference.
Yeah, and then there is AI for Science event also this Friday. So we have a lot of events this week. Okay, so thank you very much, everybody, and I'm closing the seminar. Thank you. Have a good day.